In this video, I will talk about the series combination of capacitors. Here we have three capacitors connected in series. If the capacitors are connected in series, then the charge onto each capacitor is exactly the same. That's what I have written here. So charge onto capacitor Q1 on capacitor 1 is exactly equal to the charge onto the capacitor 2 and the same as the charge onto the capacitor 3. So Q1 is equal to Q2 is equal to Q3. The same charge flows through each capacitor. The total capacitance of the combined capacitor or the net capacitance is given by this formula here. Or in other words, the net capacitance is the reciprocal summation of individual capacitor. Okay, and if you calculate this one, the net capacitance is always smaller than the smallest capacitance. Okay, again I will repeat that one. This net capacitance, this S stands for the series combination. So in series combination, the net capacitance is smaller than the smallest capacitance. Let's say this is 1 microfarad, this is 2 microfarad, and this is 3 microfarad. Then in series combination, the total capacitance will be smaller than or less than 1 microfarad capacitor. Okay, and as the same charge is flowing through this one, and if C1 is not equal to C2 and is not equal to C3, or if all the capacitors are different, then the potential across each capacitor will be different. That's what is mentioned here. For if the capacitors are different, then the potential across the capacitor will also be different. And if I measure the potential across a view on the C1, C2 and C3 and add them together, then that gives you the applied voltage potential. Now let me explain one more time about why the net capacitance is smaller than the smallest capacitance. So in series combination, the way we can think of this combination is the area of each capacitor is exactly the same, but now when you connect them into series combination, then the effective distance increases, as you can see here. Now the distance increases. As the distance increases, that means the capacitance will be smaller. And for the working voltage, as the capacitors are connected in series combination, the working voltage will be greater than even the working voltage of the highest working voltage. So the working voltage of the net capacitors increases. Now let me explain this one by using the simulation. Okay, so we have three capacitors, C1, C2 and C3. C1 is 10 microfarad, C2 is 20 microfarad and C3 is 30 microfarad, and I have applied 1.5 volt. So as I mentioned, the total capacitance has to be smaller than 10 microfarad. Let's see it. So this is the total capacitance, and you can see now the total capacitance is smaller than the smaller capacitance, or it is less than 110 microfarad. In this case it is 5 microfarad. Now the potential, as C1, C2 and C3 are different, then the potential across each capacitor would be different. Let's measure the voltage or the potential across C1. And also before that, I would like you to think about which capacitor will have the highest voltage, or which capacitor will have the greatest potential difference? Think about this one. Now, so before I answer, I will explain this one mathematically. So as you can see here, Q is equal to CV. The same charge flows through each capacitor. The charge onto C1, C2 and C3, it doesn't matter which one is the bigger capacitor, the same charge flows through each capacitor. So Q is exactly the same. So if Q is same, that means that if C is greater, the B has to be smaller, which means the higher the capacitance is, the smaller is the potential drop across it. Let's verify this one. So this one, let's measure first across C1. The C1 is 0.8. Now let's measure across C2. It has to be smaller because the capacitor is greater. It has to be smaller than 0.8, which makes sense, 0.4. And 0.4, because it is 2 times smaller, the capacitor is 2 times greater, the potential is 2 times smaller. And now this one, across this one, it has to be even smaller, 0.23, which is 3 times smaller than C1, because the capacitance is 3 times, C3 is 3 times greater than C1, so the potential across C3 is 3 times smaller than C1. Okay, so what you learn in series combination, the same charge flows through each capacitor. Okay, the higher the capacitance is, the smaller is the potential drop. The effective capacitance or the net capacitance of the series combination is always smaller than the smallest capacitor, and the formula for calculating the series the net capacitance is given by this formula, which is the reciprocal of individual capacitor. Okay, so this is it for the series combination of capacitor. Again, if you have any question, do not hesitate to write down your question in the comment section or email to me. I'll be happy to answer. And at the end, do not forget to subscribe the channel. Thank you so much.